everyone. Thank you for joining me in comparing machine learning models for heart attack risk. In this presentation, I'll compare 3 machine learning models: logistic regression, decision trees, and Bayesian networks, using one simple clinical problem, which is predicting whether a patient is having a heart attack based on 4 risk factors. I think it's always easiest to learn complex topics in the simplest forms, so we're going to pretend we have a very small data set like this one. Each row is a patient, each column is one risk factor, and the last column tells us whether they had a heart attack. And so all 3 of our models will learn patterns from this very same data. So what is logistic regression and how does it think? Logistic regression is basically a smart weighted sum of the inputs passed through a S-shaped function. Each risk factor gets a coefficient. If chest pain and high troponin are strongly associated with heart attack, the model learns large positive weights for those variables. The output is a probability between 0 and 1. For this heart attack problem, logistic regression will estimate how much each variable contributes. High troponin and chest pain might dominate the prediction, and for a patient with all 3 risk factors but not male, the model might give a 90% probability of a heart attack, which we classify as yes if our threshold is 0.5. And then on the right, as you can see, our x and y axes, the more number of positive risk factors, the more likely the probability of a heart attack. Next, we have a decision tree. And how does it learn? The most basic and simple way of explaining how a decision tree works is often how a physician would think at the bedside. If the patient has this going on, is this the cause or is this the cause? And so basically it learns if-then rules by splitting the data. If you look on your right-hand side, that is a decision tree model, and it basically keeps splitting the data into pure groups until it could decide who likely had a heart attack and who didn't. And here's how a tree might handle our variables. It could first split on high troponin. If troponin is high and the patient also has chest pain, they're classified as high risk of a heart attack. If troponin is normal, the tree may look at chest pain and cholesterol. So this is kind of the set of rules that the decision tree follows. Our last model that we will be reviewing is Bayesian network. It represents how variables are probabilistically connected instead of like a decision tree where there's a set of if-then rules. It encodes relationships such as if a heart attack is present, what's the probability of high troponin or chest pain? And on your right-hand side, that is the visual for how Bayesian networks work. It basically uses rules to compute the probability of heart attack given what we observe. And the plus side is it handles missing data naturally. So in this very example, male gender increases the chance of high cholesterol, which in turn affects heart attack risk. Heart attack risk then drives troponin and chest pain. And when we see a new patient with chest pain and high troponin, the network updates the probability of a heart attack. If cholesterol is missing, it can work by marginalizing over the uncertainty. So all 3 models can use the same 4 predictors, but they all kind of think of the problem differently. I made a little chart here comparing all the different models. Logistic regression gives us very simple and probable clear coefficients. Decision trees use if-then rules, and Bayesian networks work best when handling a lot of uncertainty in the data and missing data very well. So, in summary, all these models can be used on 4 different variables, and the choice kind of depends on what we care about most. Is it simplistic? Are we looking for interpretability? And when doing a full-on project, we would use all 3 models, and then we would evaluate them on held out data, and then choose the one that works best and fits the clinical context. Thank you for watching.